side here. So, so this is our new stuff that we're learning. And this first couple problems, you do get to use your calculator again. So bonus for that. So hopefully you still have your calculator with you. Didn't think you'd like throw it in the garbage for, you know, the rest of trigonometry. All right. So you get your calculator back because this one is nearly impossible to do without a calculator. So I actually, unless you're some sort of math wizard, I think it is impossible. So it says to remember that we have the coordinate point of cosine, comma, sine. And they want us to give us the ordered pair for each angle of rotation. And it's a weird question, but literally they're asking us to do this in our calculator and tell me what the cosine is of 195 and then what's the sine of it and just give it to me as a decimal. So like what they're basically asking you to do is do cosine of 195, comma sine of 195 as a decimal. Because 195 is not one of our nice numbers. If you tried to like estimate that, you go past 180, 15 degrees, there's no 15-degree special right triangle. So we're just getting that as a decimal. So I got like negative 0.97, right, for this one, comma, negative 0.26. That's literally all they're asking you to do. And some of you guys, if your calculator gives it to you as a radical, there's usually like a convert it to decimal button in your calculator, and we do want that as a decimal. And if you want to really think about what this looks like, 195, again, it goes 15 past. We're over here, so it makes sense that we're going further to the left and then just a little bit down. So this coordinate point actually hopefully makes sense in the grand scheme of things here. So again, that's all they're asking you to do for 107. So tell me what the cosine of 107 is, and then the sine of 107. When I was looking at these, when I first started teaching trig, and this is a problem that I don't remember as a trig student. I actually went into Mr. Hatfield's room and I was like, really, this is all they're asking us for? And yeah, it's just about where would that be on the coordinate system. Oh, this one's a positive 0.96. And go a couple decimal places. And you should be able to do the same thing with a negative 280. Your calculator should be able to handle that. It's just going the other direction. It does the work for you. And you get 2 decimals. And they typically, I can't think of it, they're not going to be over 1, either of them. And again, that's because we're using that unit circle as our as our basis for this. The cosine and sine values won't go over 1. All right. So now they want us to talk about, they're giving us the answer to a sine, and they want us to find the angle that would work for that. But they're asking us for 2 angles. And your calculator will give you 1, and we have to find where the other one is. So this is a little bit strange. So basically, if we're trying to find an angle, and they're telling us what the decimal is, we do the inverse sine of this. So to find, to find theta, we do the inverse sine of 0.743. So I do inverse sine of that. And I get like 48 degrees, right? Like 47.99, so let's go 48 degrees. But they're asking for 2 angles. Your calculator gives you 1. So we have to know, we have to use what we know to find that other angle. So, how we do that? In our triangle, or in our coordinate system, again, we're going to go back to that all students take calculus. We we have to think about where this makes sense that this triangle could exist. Now, all of them are positive in this first quadrant. This answer is positive. So that means this first quadrant, like this 48 degrees, it makes sense that this angle would be here. So our normal triangle, the one we would expect, the one we all learned about when we first learned about triangles, would have been this triangle they're talking about. And again, that's the one your calculator refers to. But we have to find, there's going to be one other triangle. Well, there's more than one. You can kind of keep spinning this around. Like you could add 360 to that. That's not exactly what we're talking about. We want to find the other one in this first spin that would also work. So since this is positive, we want to find where else sine is positive. So that's in this quadrant over here. Now, if this is the answer to this problem, the reference angle has to be the same as well. So this would also be 48 degrees. But that's not what we would write, like that would not be like what we're doing. Clayton, how many times do I need to talk to you about your phone, your earbuds? Can you put your lunchbox down? Put your phone away? You're not like, I mean, my freshmen don't do stuff like that. Stop being that way. So we need to find whether angle this is, because technically it is 48 degrees over there, but what we're looking for is what's this angle? Because again, when we talk about these, that's the angle we like call it. We say that's that angle, so we have to think about what that angle would be. And I'm going to show you guys that it actually will give us the same answer. So 180 would be here, 90 would be here. I'm going all the way over here, but I'm going just 48 short of that. So I'm basically doing 180 minus 48. And so we also get 132, right? Now if you have your calculator handy, check what the sine of 132 is. You should get that same answer, right? So we need to give this second answer. Our calculator won't give it to us. We have to use that second answer based off the fact that it's out there. We need to know that it's a possibility as well. Okay? I'll do another one to make sure we're good on this. Like it's kind of strange, like thinking about, you know, your calculator doesn't give you all the answers. So our cosine here is 0.809. So in this case, again, we do our inverse cosine of that. So like 36 degrees, right? Almost exactly. And again, we want to find where else that works. So here's my 36-degree angle. That's the one we know about. All students take calculus. So our other place we need to put it is where else cosine is positive. So that's going to be in this fourth quadrant down here. So again, my reference angle is 36 degrees. But we have to think about what angle that is starting from the start from 0. Like, so if I spin that around, how am I going to find that?
36 minus 360.
Yeah, so we're taking 360 would be the whole way, and we're just 36 short of that. So 320, so it just becomes, yeah, a subtraction problem. So 324. And again, you can check that works by checking the cosine of 324 should be 0.809. It's the other answer, again, that your calculator kind of leaves out. All right, questions there? All right, so our next thing is these coterminal angles, and this is kind of similar to what we were just talking about. Basically, coterminal, terminal, you think about where something ends. It's like the like there's when I'm a trail runner, and like they always talk about the terminus of a trail, and that means the end of the trail. I don't know why it's called the end, but so it's angles with the same endpoint. So like, yeah. Yeah, so that's, well, no, not necessarily. They're kind of like, it's kind of like that. We actually want to end up exactly the same spot. So it's like saying like, so I'm at 36 degrees, but if I spin that all the way around again, that's another, that I'm at that same angle again. So it's kind of like the hands of our clock right now, like, so let's say we live in Alaska where it's dark like all day. And they, you know, they look at the clock and it says, you know, 8:35, but if we were here tonight at 8:35, we would know it's night because it's dark. But if we were someplace where, you know, again, it's dark like all day or something like that, 8:35, the clock looks the same. It's not technically the same time, it's not technically the same angle, but it looks the same. So basically, if I spin it around again, are we in the same place? So 36 and negative 342. So what you're kind of checking is, am I spinning my hands and my clock 360 degrees? Are these 360 degrees apart? So you're checking the difference between them. And if you check that, they're 360 degrees away from each other. So I could do 36, or I could do a negative 324. Again, I'm here, or I go this way, and I'm at the same spot again. So these are considered coterminal angles. Now 123 and 237, I hope you look at those and do not think they're 100 or they're 360 degrees apart. So since the difference between them is not 360 degrees, they are not coterminal. And again, you could draw and see what they look like too. So 123 would be like over here, 273 would be like over here. So this one's no. I don't even know what I was trying with that one, like trying to, I must have come up with some, like maybe they look the same or they use the same reference angle or something. Now this next one's a little bit strange because you're going to notice they're not 360 degrees apart. But if I take, because 780, what is that? Yeah, it's 720, but that's 2 rotations. So, like, so if I do 60 plus 360, I get 420. If I add another 360, I get 780. So it's the same angle, it's just they're rotating twice. So almost like the next day, like tomorrow again, this clock will stay the same time because it's rotated twice. So it's 2 rotations. So yes. So basically, is it a factor of 360 apart from the previous angle? And again, you could think of it a lot of different ways. So we're at 60 degrees here. If we go around another 360, around another 360, then we're back at the same spot again. Now this next one again is trying to get us to name another angle, but they want us to stay under 360 degrees. So they don't want you just like spinning around again. So basically I want to know the angle that we could use that same measurement for. Now this first one's a little bit the negative idea. I actually think these are sometimes are a little bit easier. So negative 30 degrees is here. So I need to figure out what this one is, because it's the same angle. So negative 30 versus the purple one. Yeah, so this would be 330. Now 620, so we go 360. What are we at then? 620 minus 360. We're around 1, so we're at 260. That's it, right? So we take away 360. We're at 260. That's going to be the same angle. We took off like one whole spin. So it's basically, we're like adding 360 or subtracting 360 depending on the problem. So take away 360 again. So we're at 210. So it's almost like taking away 360 in these is almost like simplifying a fraction. Like 5 halves or 5 tenths is the same thing as a half. That's essentially what they're doing here. Okay?